All right, so I think it might take a few seconds for people's audio to connect, but I will start welcoming everyone to the Urban Fix Resilient Cities. The learning objectives for the session are shown here, and we'll be following up with a survey and with more information on how to receive credit from AIA. We'll collect questions submitted to the Q&A box throughout the session, and if the speaker isn't able to get to the questions, we'll have them answer in writing and share them on the website after the teach-in. And now it's my pleasure to introduce the speakers for this session, Doug Kelbough and Harrison Fraker. After 2 degrees from Princeton University and an active professional practice, Professor Kelbough, FIAIA, served as architecture chair at the University of Washington, and then Dean of University of Michigan's Taubman College of Architecture and Urban Planning. Author and editor of numerous books, chapters, articles, and essays, he won the 2016 Topaz Medallion, the highest award in architectural education. The Topaz Medallion is an honor our second presenter, Professor Fraker, also shares. After receiving his architecture degrees from Princeton and Cambridge universities, Professor Fraker taught for 15 years at Princeton, was the founding dean of a new College of Architecture and Landscape Architecture at University of Minnesota, became the 5th dean of the College of Environmental Design at UC Berkeley from 1996 to 2008, and was a guest professor at the Sustainable Urban Design program at Lund University in Sweden over the last 10 years. An award-winning practitioner, author, and committed teacher, he won the 2014 Topaz Medallion. Oops, the session is just beginning, and I will pass over the screen to our first presenter, Doug.
Good morning indeed. It's 4:15 or 4:45 here in Seattle, Washington, and Harrison Fraker, my colleague, is down in Berkeley. It's the same time there. And welcome. Here we go. For us, these workshops go way back. Harrison and I offered this one back in the 1970s in Princeton, New Jersey, where we both studied architecture and lived. We dedicate this to a fellow Princetonian and passive solar pioneer named Don Prowler, who died way too young. So my talk today is based on this book, my latest book, and it goes back to this solar house designed in 1973 in Princeton, a passive solar tram wall house, and also it's based on a half-century of work designing and building projects around the country and in some abroad. So we're going to talk about cities today because they are the focus of so many of our challenges and opportunities, from housing and homelessness to community and livability, and the other issues listed in between there. The built environment, especially the city, is society's biggest economic investment. We spend more money on that than on healthcare or defense. It's also one of humanity's most empowering and monumental achievements. And you may ask, why is it so relevant now? Here are 3 reasons it's critical at this moment. One is there's a global tsunami of urban development, as you know, all over Asia in particular, but also Europe and Africa. And the world is urbanizing fast. It's becoming more and more a planet that is a planet in which people live in urbanized areas. Europe is, of course, much more urbanized than Africa, or in fact, than North America, where we both live. This is a map of the world with the 300 largest cities, and they account for about half the world economic output, even though they are inhabited by only 1/5 of the world population. And you can see there are many, many in Europe on the upper left, not many at all in Africa, but it's changing. Rural residents have been flocking to cities since World War II. It's been accelerating recently, particularly in South Asia and East Asia. So a second reason cities are very relevant now is the ecological crises we're facing, particularly climate change and other challenges that are evident in both Europe and Africa. Flooding is typical. Here's a famous city in Europe, which is flooded frequently, Venice. And as a famous landscape architect, Ian McCarrick says, few among us regret the loss of ancient marshes on which Venice and Amsterdam sit, the loss of the even more ancient hills which now seat Athens and Rome. The point is, we want to save our marshes and sensitive environments, but it's okay to sacrifice some for cities of the quality of Amsterdam and Venice. There are other big ecological challenges, from COVID to fires, which are burning right now where we live. There's smoke in the air, immigration, and drought, and so on. Global population, or overpopulation, I would argue, is the third reason cities are so relevant now. The population of humans has exploded. As a species, it's been hyper exponential. It took the planet until 1830 to hit 1 billion, and we added the last billion in just 11 years. So it's literally exploding. 50 years from now, depending on how fast the rate of growth is and on climate change, up to 3.5 billion people could be living in places so hot that today they would be considered uninhabitable. And Africa will certainly be on the front line. We've had 10,000 years of near perfect conditions for our species to thrive, starting in Africa, as we all did. That's changing. You don't have to look at this chart too carefully to see it's gone from blue to red. It's getting hotter and hotter, and it's accelerating. Harrison and I will do fine. We're old, but our kids and our grandkids will go through very different lives that will not be, in the end, very tolerable. So here's a slide that shows the atmospheric carbon dioxide cycle over 100,000 years or so. It goes up and then it goes down, up and down, hot and cold, and then it cools off. But in fact, the CO2 level on the far right there is much higher than it's ever been before. So this is why President Trump is wrong when he says, don't worry, it's going to cool down. It's not going to cool down, at least not for a very long time, because of greenhouse gases in the air. Restraining average global temperature to 1.5 degrees Celsius above the pre-industrial period, which is what the UN is hoping we can do, would be less costly by at least a factor of 4 or 5 than the damage due to inaction on global climate change. So it's much more expensive not to act than to act, although acting is going to get increasingly costly. So the city is not analogous to an ecosystem. It is an ecosystem. It's just as natural as a colony of prairie dogs or a beehive or a bird nest. Like ecosystems, cities don't have to die. All organisms die, every organism dies, but not an ecosystem. It can live on and on, as cities like Athens, Rome, and Beijing, and Cairo in Africa, certainly Rome, as all Europeans know, goes way back many millennia. Now we're going to shift gears to something called the environmental paradox of cities. Stick with me, it's a little complex, but when people cluster, when they live in dense mixed-use cities rather than in sprawl, suburbia, they have a big ecological footprint. Cities have huge footprints. London has a huge footprint. Paris has a huge footprint. Cape Town has a big footprint. But their ecological footprint per capita, per person, is smaller than in low density patterns of development like suburbia. This is important. This is the big benefit of urban living. smaller eco footprints, energy footprints, environmental footprints. So cities might not look as green as the suburbs or the countryside, but in fact, they are greener in ecological terms. And that's because if you look here at these three colors, red is what people spend on transportation in terms of energy. Purple is building operations. That's heating and cooling and lighting buildings. And green is the materials that go in to a building, as well as the energy that goes into constructing the buildings. And the upper bar is a low density area, and the high density area is the second bar. That's the city. What a difference. It's a factor of more than 2 here. It's quite dramatic. Here we compare Atlanta, Georgia to Barcelona in Europe. And you can see how big Atlanta is in area compared to Barcelona on the right. They're both about 2.5 million people. Barcelona is actually a few more than that. The
Look, you're
urban
about
area is
halfway through.
vastly different, but relevant to today. The transportation carbon emissions, greenhouse gases from moving around, are 10 times greater in Atlanta than in Barcelona. This is because Barcelona is more compact, more walkable, bikeable, and has good transit. Europe has done a great job at decreasing its ecological footprint. You can see in the 1990s how dramatically it dropped for lots of reasons. Blue, the bottom blue is carbon dioxide, but the other things were improved as well. It is true that there were some countries that dropped out of the EU that year, that decade, so it's a little more complicated than that, but it's a remarkable reduction that Europe should be very proud of. Africa is the most undeveloped continent. It's also the second largest continent. It's huge. It's expected to add 1 billion people. At one point, the UN was saying 2 billion. I find that hard to believe, but it's a lot of people that are being born. The population of the planet may peak at 9 or 10 billion. I don't know if the ecosystem will support that many people. It's quite possible there'll be a die-off at some point. But in any case, Africa is exploding in these large, hot cities. Unfortunately, the massive poverty and disease is part of that explosion. But ironically, in these international surveys done by the UN, Africans are always rating themselves the most optimistic people on the planet. They're very upbeat with a great attitude. This is from yesterday or 2 days ago, The Economist. Just 4% of African countries have mapped and titled the private land in their capital cities, not to mention all their regional cities. It means that the land that most of these people squat on has no real estate value, and there are lots of problems with that. Africa also has half of the world's uncultivated land that is cultivatable, and its agricultural productivity is way below its potential, as the Africans know that are on this webcast. It's a huge drag on growth. Switching gears to heat, urban heat in particular, we should realize there's something called the urban heat island. Europe is full of urban heat islands. It results from the buildup of heat from exhaust, the hot tailpipe emissions from vehicles, and also from chimneys, and from the dark surfaces, the dark rooftops and the pavements that get heated up during the day by the sun. This has nothing to do with the science of climate change. It is a local phenomenon. It's simply about hot air. Nothing to do with sequestering CO2. Large cities in the US, and this would be true of Europe as well, are warming up at more than twice the rate of the planet as a whole, or the rural countryside or hinterland of a given city. Global estimates of climate change are likely to underestimate the rates of warming in the very places where most of the global population now resides, cities, as we've seen. So it's getting hotter fast where most people live. Here's a cross section of a city from the air showing how hot the more urbanized paved areas are on the left, to the countryside on the right. This is surface temperatures, not air temperatures, but they're also hotter. On the other hand, we're very lucky. Strategies to mitigate and adapt to the urban heat islands of the planet are consistent. In fact, they're identical with strategies to deal with climate change. So when we're dealing with urban heat islands, we're dealing with climate change. And I argue in my book that because urban heat islands are manageable in a much shorter time, you can cool your city down in 5 to 10 years rather than the 50 to maybe 100 years it'll take to stop climate change. There's more, well, we're not going to stop it, but to slow it down anyway. There's more immediate and more palpable feedback with by addressing urban heat islands. And I think that better motivates people to change their behavior. And how do we cool down urban heat islands? Well, lighter colored pavements make a huge difference. A lighter pavement can be 4 times cooler than a dark pavement. And that's true of rooftops as well. We're the simplest solar technology, which makes sense in Africa and Europe, is simply painting a roof white. It will reflect up to 4 times as much solar energy back into the sky as a dark roof. And as you know, many roofs tend to be dark. Green roofs, those are ones that actually grow grass or plants on the top, and including edible food, are wonderful in hot climates. They do a good job of not only cooling the building, but white roofs are not only cheaper, they're actually more effective at countering climate change than green roofs.
So you got about 5 minutes.
There are other good reasons to do green roofs, but white roofs are technically more effective. This is the white rooftop of the condominium in which we lived in Michigan till we recently moved to Seattle, and you can see it's a white roof, and then there are photovoltaic collectors in the foreground which are making electricity, and the tilted collectors are producing hot domestic water, meaning we have to burn less gas to heat water. Very effective, and we could sell back the excess solar energy in the summer to our utility in what's called reverse metering. Another way to reduce heat islands is less waste heat from vehicles. More walkable, transit-served, less auto-dependent cities address that issue. This is a bigger and bigger deal in Africa, where there are more and more air conditioners, and they really are city heaters. They may cool off interior space, but they heat up the street and the city's air. To deal with heat waves, the number of AC units is expected to more than triple worldwide by 2050. I hope this doesn't happen, because AC units contain potent greenhouse gases in the actual chemicals within the unit. Air conditioners are the fastest growing source of greenhouse gases in every country on Earth, including Europe. Then there's street canyons, which trap heat in cities. We need to make them wider and not so tall. Manhattan being the worst example, but there are many, many narrow streets in Europe that get hot. We need lighter pavements, but also lighter colored surfaces on the walls, the street walls of those canyons. It's actually getting so hot in some cities. Here we are in Beijing. They're talking about tearing down taller buildings to get more air circulating through the city and flushing out dirty air and hot air. Lastly, cool microclimates, particularly trees. that shade and filter and cool the air are the way to deal with urban heat islands. Trees are the great multitaskers. Look at all the wonderful things they do, from beautifying the city to providing fragrance and places for birds, and they produce oxygen and sequester CO2, and they even reduce crime and increase real estate values. They are the win-win-win species on the planet. And because urban trees grow bigger, they can form a sort of cathedral-like space in cities. They grow so much bigger than trees in the countryside, which are competing and much more closely planted to each other. They're 16 times more effective at mitigating, up to 16 times more effective at mitigating climate change than non.
You got about a minute.
And we need more water to reflect sunlight back into space, but also evaporative cooling. So what do we need to do? We need to eat plant-based diets. We need to avoid air travel. We need to live car-free and have fewer children. You should eat locally and compost your waste food and replace a conventional car if you can with the electric bike or electric car, and wash your clothes with cold water and hang them outside. Install solar collectors on your roof or on the side of your building, and be careful with the thermostat, minding it to cut down energy use. And don't eat beef and lamb. They're 10 times the amount of water and energy to produce a calorie of beef than, say, chicken or pork. Now, here's the little miracle that shows we still have more than our share of good luck. At exactly the same time when it became clear that we have to stop burning fossil fuels, a wide variety of other technologies for generating energy became available. We're very blessed. And don't forget to share things in the economy, which has lots of wonderful names. It's a very effective way to deal with climate change, because we don't have time to solve all these problems listed here in the circle by a colleague of mine. We have to be synergetic. We have to deal with multiple problems at once. We can't deal with them one at a time. But while we're dealing with them, don't forget to dance and enjoy yourself. If you want my book at a discount, let us know later. And here's Harrison.
Okay.
Now I have to stop sharing here.
Yep.
And you are on, Mr. Fraker.
Thank you. Let's see if I can get this. There we go.
Excellent.
Thank you.
All right. So, I want to focus on three important concepts, how-to for resilience and sustainability. One is integrated whole systems thinking, which deals with buildings, transportation, energy, etc., water, waste, food, and microclimate, and to see those as a synergetic design problem. I want to focus on what I think is an underdeveloped design opportunity, which is the environmental performance of public space. And I want to remind everybody that making public space more meaningful is really what we should be doing. We should be capturing the sensory and aesthetic potential of sustainable systems. It turns out that whole systems thinking really begins with transit-oriented development, where we privilege pedestrians, bikes, public transit, etc. This is the eco block in China. But it also involves buildings with deep energy efficiency, where you use the building also for PV solar or micro wind or hot water collection. You can also collect the organic waste, sludge, and green waste and generate biogas. You can collect and treat the wastewater and treat it for various appropriate uses, gray water, irrigation, or drinking water. There's no silver bullet. You have to use all of these steps to get to zero carbon, but it actually is very feasible and economic to do this at the block scale. It's also a great strategy as a retrofit strategy. This is the eco block in Oakland, where you use the roofs to create a community microgrid that goes to a vacuum flywheel storage. It's all DC until, so you can charge cars and light street lights Then it goes to an inverter and either goes back to the houses or to the grid. You can do the same thing with water by collecting rainwater for potable, but you can also use treated sewage to remake the microclimate of the street. And what's amazing is all of this can be done from, the cost of doing this can be done from the savings from your existing water and utility bills, and especially the miles that you've now done electrically. I looked at first generation systems for how to, and the interesting thing is, if you look at the 4 that I chose in BOA 1 in Sweden, wind and groundwater heat pump provided 100% sustainability or renewable energy. In Hammarby, also Sweden, they used combustible waste to energy, which provided 25% of the demand. In Kroonsberg, they used wind and cogeneration to provide 50% of the renewable energy. And in Vauban, they used passive solar efficiency PVs and an organic cogeneration to be 100%. But the big discovery in these places was how spectacular the urban landscape was in treating stormwater, enhancing the microclimate, and the aesthetic impact. And what this points to is that the potential in urban design is for sustainable systems to actually touch the sensorial and the aesthetic potential of creating better places. And Scarpa's Biennale Courtyard is just an amazing sensory oasis where you have sun and shade, you have a microclimate with evaporative cooling and evapotranspiration. And then you have smell and sound. These water lilies are copper water lilies that tinkle, but they reflect their rings on the soffits. So this is an oasis of sensory delight. The problem is that urban design has, in some cases, focused on the public realm as a figure ground space, formal spatial performance, or as a social performance. Think of Jan Gehl. The public realm as the place for all forms of transportation, and also the public space as the space of infrastructure performance, where we've been trying to hide it and get rid of it, when in fact we can retain it and make it part of the space. When you look at the environmental performance of public space, just like Doug's trees, it turns out that the first 10 on this list, the microclimate, the air quality, the CO2 absorption, stormwater treatment, wastewater treatment, food, habitat, energy creation, and aesthetics and health, are all underdeveloped. We've usually used public space for transportation, all modes, and for our social interaction in plazas and in parks for recreation. But streets have a huge underdeveloped potential for environmental performance. They equal 35% of the total land area, 75% of public space. And if you look at the environmental section, rather than just the plan, it is the space of environmental performance, but it's been a dumping ground. Waste heat from air conditioners that you saw in Doug's pictures, all the light and sunlight that's absorbed, increasing the urban heat island, and waste from vehicles. The urban section, though, when you look at it, it demands that building envelopes and public space and transportation be designed as an integrated whole. We need to rethink all the surfaces and systems. And I'm going to roar through these. So if we look at urban floors and you change from concrete to a living floor, look at all the wonderful things you can do. Temper the climate, absorb and retain stormwater, recharges groundwater. It's a carbon sink. It can actually treat the stormwater as we see in these other ones, and it can even be a source for evaporative cooling, but it has immense aesthetic potential. Same with urban walls. And these are green walls where you can have urban screens, separate structures. You can have green fins, you can have green screens, and they do many of the same things. Trees, Doug focused on these, but their potential is just extraordinary. And it's especially because of their changing qualities. You know, wonderful smell and flower in the spring, dappled light, cathedral spaces, leaves in the fall, sunlight let in, amazing. But they're not the only way to deal with the heat island effect. You can have fabric awnings, you can have green trellises, and you can even have energy generating trellises that also have all of these eco functions and co-benefits. Doug talked about white roofs. They're wonderful. They really are inexpensive, and you can even occupy them so that they're part of the urban experience, not just reflecting sunlight. But the roofs can also generate energy, as you can see in these other photographs. And then, of course, there are the multi-functions where you can grow food, you can have a garden, you can even have a social community up in the air with bridges between things. So it's a new urban ground. What happens in these places, though, is much more than a technical fix. If you look at Paley Park in New York, which does reduce the heat island by 10 to 12 degrees Fahrenheit, we really, as neuroscience has shown us, it is a meaningful place because we empathize with the entry and the room that's been created. It affords many ways of occupying and sitting. It has an amazing environmental performance with shade, evaporative cooling, and evapotranspiration. The sound, the smell of the water wall, the touch of the materials, all of this dappled light really create a memorable and meaningful place beyond just its technical performance. And this is a kind of higher order opportunity that we have in the public space of cities. And so here are a few examples where we took a look at how you might be able to create a climate oasis in Harlem, where you get 70% shade cover on the cross streets, the east-west streets, and then you have a device to shade the avenues. This is the Malcolm X Avenue in Harlem. Or you can even turn the cross streets in Manhattan into power plants, where you get an 18 megawatt of renewable energy for each one of these cross streets. It makes a shading device, you create this wonderful hanging garden, and you develop a whole new unique spatial identity that connects the two rivers in Manhattan. Unlocking the creative and sensorial and poetic potential of these sustainable systems is in its infancy. It could create a whole new urban design toolbox. And this book, the cover on the right, presents preliminary field notes on how to unlock this potential. It should be available late in the fall in December. And I want to thank you. Hope you'll take a look at this book. It really could be a whole new language of urban design. Thank you.
Thank you, Harrison. I guess we're on to Q&A.
Yeah.
Thank you so much. So we only have time for a few questions, but just a reminder for the audience that if you submit questions to the Q&A box and we don't get to them in time, we'll answer them in writing and share the answers on the website. But let's start with this question. How do we continue to push forward with public infrastructure projects in the short term and the long term, given the historical lack of investment in the US and the most recent COVID impact on city budgets?
Doug,
Well,
I could take this because
yeah,
I
go
talked
ahead.
a little bit about it. At some point, because of the economic challenges that we have, I really do think there's going to be, some form of either a Marshall Plan or a Green New Deal, where there will be major public works investment. And the question is where to spend those. And I would argue that our cities, and especially the disenfranchised neighborhoods, would be the best place to start.
Which is so true in Africa. There's so many neighborhoods that have no infrastructure whatsoever. On the other hand, Europe has the most developed urban infrastructure on the planet because the cities have been in existence for a long time and they're compact, which makes the cost of infrastructure less. But in Africa, probably more than any continent, building infrastructure is a #1 challenge.
The politics of that are admittedly very challenging because so often infrastructure projects are not necessarily done well, and there's a history of corruption in the process around the globe. Even during the New Deal in the US, there was tremendous favoritism and corruption that took place. Nonetheless, investing in infrastructure is certainly a way to get the economy going again and really starting to address the issues that are the subject, of this webinar, which is trying to reduce our carbon emissions.
And in Africa, a big challenge is actually getting the internet.
Yeah, the communication
For
part.
everybody, communication
really
is so important.
Yeah.
So we've got one more question and just time for one more question. How do we avoid the heat trap in streets, and what's the good proportion for the right-of-way to ensure air circulation in hot climates like Abu Dhabi?
Well, I lived in Dubai for a while, so I'll take that. The best cross-section is a ratio of 1:1. The vertical walls no higher than the width of the street. Wider than that is even better. But when you start to get deeper canyons, they do trap more heat. However, the color of the walls on the buildings on either side and the color of the sidewalk and the pavement makes a big difference. And of course, adding trees, or as Harrison eloquently pointed out and illustrated, having shading devices. They make a lot of sense in places like Abu Dhabi.
Yeah, I mean, the nice thing about those awnings, and there have been some really good scientific analysis, when you place them quite high at 6 to 8 stories, the breeze still is able to go through the streets. Sometimes if you plant trees too densely in cities, it can choke off the natural ventilation. So it all depends on the microclimates of the cities and the orientation of the streets, and therefore a really careful microclimate design of the public space. But what's also nice, if you could make the shade movable, it does expose the city to the night sky, which is what happens in most hot climates. The city doesn't come alive until 10 or 11 or 12 o'clock at night. Just look at Spain.
But speaking of alive, we are no longer live.
Well, you are still live, and I'll just thank the audience. Thank you, and thank you both for waking up and giving this wonderful presentation. Everyone can find the next session that you would like to join through the agenda of the CarbonPositive website. Thank you.